All right, let's look at 6b. Now, the only difference is that we have a subtraction sign here instead of an addition sign. So remember, you're going to need to distribute this negative. So that's going to be negative 3, and then negative times negative is going to be a positive square root of negative 9. So just like a moment ago, we said the square root of negative 9 would be 3i. So you can see square root of negative 9 is 3i. So now let's combine our like terms. So 2 minus 3 is going to give us negative 1. And 3i plus 3i would be 6i, just like 3x plus 3x would be 6x. We want to be sure that we write our answer in a plus bi form. All right, then the next one that they give us, they want us to multiply imaginary numbers, all right? So to multiply, I need to FOIL. So I'm going to go through and say 2 times negative 1 is negative 2. 2 times negative 4i is negative 8i. 3i times negative 1 is negative 3i. 3i times negative 4i would be negative 12i squared. All right, so I squared, remember, is the same thing as negative 1. So let's replace I squared with negative 1. So negative 12 times negative 1 would be positive 12. Then combining like terms, I could put my negative 2 and my positive 12 together, and that'd give me positive 10. So a plus bi would be 10 minus 11i. All right, for division, remember that you cannot have an I in the denominator. And so to get rid of that, we're going to multiply by the conjugate. It's the exact same numbers, but the opposite sign. So I'm going to multiply by 1 minus 2i, and what I do to the bottom, I have to do to the top. So that means that we're going to need to FOIL our numerator and FOIL our denominator. So let's start with the top. So 3 times 1 is 3. 3 times negative 2i is negative 6i. Negative I times 1 is negative I, and negative times negative would be positive. I times 2i would be 2i squared, so positive 2i squared. All right, if we keep simplifying that numerator, I squared is the same thing as negative 1, so that would be 2 times negative 1. And of course, negative 6i and negative 1i would be negative 7i. So if I have 2 times negative 1, that's negative 2. So I could say 3 minus 2 would give us 1, and then minus the 7i. All right, let's see about FOILing the denominator. So 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i. And positive times negative is negative. 2 times 2 is 4. I times I is I squared. All right, so the negative 2i and the positive 2i drop each other out. I squared is negative 1, so negative 4 times negative 1 would give us positive 4, and 1 plus 4 would be 5. Now we want to write this in a plus bi form, which means we need to break it apart and say 1/5 minus 7/5 I. So 1/5 minus 7/5 I would be a plus bi form. All right, then for number 7, we move into the graphing calculator portion now. So you will turn in the first page of your test, and then you can get out your graphing calculator to use for the remainder of the test. All right, so for this first one, it says to simplify. The only way you can add two fractions is if you have a common denominator. So I need a common denominator for d plus 1 and d minus 1. So that common denominator would just be d plus 1, d minus 1. So to get from here to here, we had to multiply by d minus 1. If I do that to the bottom, I got to do it to the top. So I'm going to have 2 times d minus 1. To get from here to here, we had to multiply by d plus 1. So if I do it to the bottom, I got to do it to the top. So that's going to be 5 times d plus 1. All right, so why do we get a common denominator? We get it so that we can combine. So we want to combine these two numerators over that common denominator. All right, so for our numerators, we're going to have 2 times d minus 2 times 1. So that'd be 2d minus 2. And then plus 5 times d, 5d. And then 5 times 1, 5. So combine any like terms we can. 2d and 5d would give us 7d. And negative 2 and positive 5 would give us positive 3. And we can just leave that denominator factored out. If there's anything that I could factor in my numerator, I would want to do that and just make sure there was nothing that I could factor and cancel. All right, for the second one, it's the exact same thing. The only difference is instead of a plus, we've got a minus. So we're going to start the same way with getting that common denominator. And this is identical, and this is identical. The only thing different is that instead of addition, we have subtraction. So we have to be careful to distribute this negative to everything that comes after it. So you can notice that this is going to be a negative 5d and a negative 5, just like this was a positive 5d and a positive 5. So it distributed to both of those terms. All right, so then combining like terms again, 2d minus 5d is negative 3d, and negative 2 and negative 5 is negative 7. So again, if there's anything that I could factor, I would want to factor and cancel, but if there's not, then that is my answer in lowest terms. All right, then for C, they ask us to divide. Now remember that division is the same thing as multiplying by the reciprocal. So when we're dividing, we're going to stay, change, flip. All right. So to begin with, I'm going to go through and factor everything. So d squared minus 1 is a difference of squares. That's d plus 1d minus 1. D squared minus 4 is a difference of squares. That's d plus 2d minus 2. And then this guy would break down to d minus 6 times d plus 1. All right, so again, we want to stay, change this to multiplication, flip this fraction so that we're multiplying by the reciprocal. All right, then we want to see if there's anything that can cancel out. So you'll notice that my d minus 2's drop out and my d plus 1's drop out. So remember, when you're canceling, you can cancel up and down. You can cancel diagonally. You just cannot cancel horizontally. All right. So in the top, that's going to leave me with 1 times d minus 6 times 1. So d minus 6. And in the bottom, 1 times d minus 1 times d plus 2 times 1. So d minus 1 times d minus 2. And I can leave it in that factored form. That's perfectly fine. All right. For number 8, it said, given these 2 points, find the slope of the line. All right, so I'm going to call this point 1 and this point 2. Wouldn't matter which order you used. So this would be my x for point 1 and my y for point 1. And this would be my x for point 2 and my y for point 2. All right, so I'm going to use my slope formula, y2 minus y1 over x2 minus x1. And so I'm just going to plug in y2 minus y1 would be negative 1 minus 4. And x2 minus x1 would be negative 2 minus 3. All right, so negative 1 minus 4, negative 2 minus 3 is going to give us negative 5 over negative 5, or positive 1 for our slope. All right, then they asked me, what would the slope of a line parallel to that be? Parallel lines have the same slope. So if my slope is 1 for this line, then the parallel line is also going to have a slope of 1. All right, then it asked me for the slope of the line perpendicular. Perpendicular is going to be the opposite reciprocal. So that means that it's going to change signs and it's going to flip. So if I have a positive 1, if I change signs, that'd be a negative 1, and it's negative 1 over 1. So if it flips, it would still be 1 over 1. So negative 1 would be my perpendicular slope. Look at another one of those. Let's say that your slope was negative 1/3. All right, if your slope was negative 1/3, what would your parallel slope be? Well, it'd be the exact same thing, right? Negative 1/3. What would your perpendicular slope be? Well, it would have to be the opposite reciprocal. So if this is negative, it would have to be positive, and then I would have to flip my 1/3 and get 3 over 1. So the parallel slope would be negative 1/3, and the perpendicular slope would be positive 3. All right, then they ask us to create the equation for the line that's passing through those 2 points and to put it in standard form. Okay, so I know that my slope is 1, and you can choose either one of these points because you need a point and a slope. So I chose 3, 4 just because both of those were positive and I wouldn't have to work with negatives. All right, so I'm going to use my point slope form. You also could use your slope intercept form, y equals mx plus b, whichever you like better. So I'm going to plug in 1 for my slope, 3 for x1, and 4 for y1. So 1 for my slope, 3 for x1, 4 for y1. So that would be my answer in point slope form. All right, they wanted it in standard form. All right, so I can go through and I can distribute my 1. That would give me x minus 3. And I could add that 4 to both sides, so that would be y equals x plus 1. So if they said put it in slope intercept form, there's slope intercept right there. They said standard form though. So in standard form, x and y have to be on one side and the constant on the other side. And remember that the coefficients of x and y have to be whole numbers. They can't be fractions or decimals. So if there had been a fraction here, I would have needed to multiply by whatever it takes to clear that fraction. So standard form would be negative x plus y is equal to 1. All right, then for number 9, they ask us to solve the quadratic. So this one they say by completing the square. And you do have to solve it by the method that's indicated. We've already done quadratic formula. And so this guy would be by completing the square. So step number 1 in completing the square, we're going to move our constant over to the other side. So we're going to take that negative 2 and add it over to the other side. Then remember that we take the coefficient of the middle term, 6, we cut that in half, and then we square it. So coefficient of the middle term, cut in half or divided by 2, and then squared. All right, so for us, 6 divided by 2 would be 3, and 3 squared would be 9. So we're going to add 3 squared, or 9, to both sides. All right, so then when I go to factor this, I'm going to get x plus 3 times x plus 3, or x plus 3 squared. Remember our little trick that whatever this number was before you squared it is always what's going to be here. And then 9 plus 2 would give us 11. All right, then we use the square root property. So insert a square root on both sides. When you do, be sure that you put in a plus or minus. So insert a square root on both sides with the plus or minus. Square root and the square cancel each other out and give us x plus 3. And then to get x by itself, we would just subtract that 3 from both sides. So negative 3 plus or minus the square root of 11 by completing the square. All right, then for these next ones, they want us to solve these algebraically. So we're not putting them in the graphing calculator and using some kind of solver and having it do it for us. We're working these out by hand and giving the exact answer, not the decimal approximation from our calculator. Okay, so remember that when you have fractions in your equation, you can multiply by the least common denominator to make all of your fractions magically disappear. That would be one way we could do this problem. However, remember that when you have one fraction equal to another fraction, you can just cross multiply, right? So that would be a much simpler way of doing this. So you could do it either way, but cross multiplying would definitely be simpler. All right, if you had multiplied both sides by 3x and x minus 1, you would have gotten the exact same thing. All right, so now we need to distribute. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. 5x times x is 5x squared. 5x times negative 1 is negative 5x. 2 times x is 2x. And 2 times negative 1 is negative 2. So let's simplify here. Negative 5x and positive 2x would be negative 3x. And then let's get it all on one side set equal to 0. So subtract 5x squared from both sides. Add the 3x to both sides. And add the 2 to both sides. All right, so once you get your quadratic, you can decide if you want to solve by factoring, quadratic formula, or completing the square. If it'll factor, that's the easiest way, but if you'd rather use quadratic formula or something else, that's fine. But here are the two factors that we get when we factor it down. So we can set each of those equal to 0. So if 4x minus 1 equals 0, add 1 to both sides and divide by 4. x minus 2 equals 0, add 2 to both sides, and x equals 2.